So when doing mole math problems, we're really doing dimensional analysis problems, and we need to have conversion factors, and so that we can multiply and cancel out the units until we get to the units that we want to. And we have several dimensional conversion factors that we use in mole math problems. Really, there's basically only 3 different conversion factors we use in almost every mole math problem. The first one we've talked about is at gases at STP. There's a special one to use for gases at STP, and of course that is 1 mole of a gas will fit into the volume of 22.4 liters. Now these conversion factors, we know there's always 2 ways to write them. You could write them either as 1 mole over 22.4 liters, or you could write it as 22.4 liters over 1 mole. Either way is acceptable. The one you're going to use is depending on what units you want on the bottom and what you want on the top. If you were in moles and converting to liters, you'd use this one over here. So your moles would cancel out and you'd have liters on the top. If you're in liters and converting to moles, of course, you'd use this one over here. So it just depends on what the dimensions tell you to do. Keep in mind, this one here is only for a gas at STP. Sometimes we get carried away and want to use that all the time, and we can't. It's only if it's a gas at STP. The other conversion factor is that 1 mole of anything would equal 6.02 times 10 to the 23rd representative particles. And I say representative particles here because we don't really know what that representative particle might be. If we're talking about an element, the representative particle would be atoms. If we're talking about covalent compounds, the representative particle would be molecules. If we're talking about ionic compounds, the representative particle would be a formula unit. So we can use this, and of course we can write it in the 2 ways that we mentioned over here also. And then the last one is 1 mole of a substance would equal the molar mass of the substance in grams. And you'll notice this is the only conversion factor where I couldn't actually write down a number for you. This conversion factor over here and this one here, we don't even need to know what the substance is. Those are true for any types of material I can use. So if I have a problem and they don't even tell me what the substance is, I'm using those conversion factors probably. However, this one requires me to know what the substance is so that I can look on the periodic table and add up the molar mass for the grams for what 1 mole is. So these are the 3 conversion factors that basically I'm going to be using in any problem. And I can write them, either 1 mole over the molar mass or molar mass over the mole. I can write them either way, depending on how I want to use the units. You'll notice, if you can think about it here, that technically there's some that we could really kind of combine. So I could combine this one and this one, and I could say 6.02 E23 representative particles should equal the molar mass of that substance. So if I have that many representative particles, it'd equal the molar mass in grams. Or I could have this many particles equaling 22.4 liters if it happens to be a gas at STP. So I could actually just kind of combine those. We're not always going to combine those because maybe I'm trying to convert from moles to representative particles, then I'd only be using this. But if grams are involved and I'm going from like how many representative particles there are and how many grams, then I could actually combine these 2 kinds of things. So let's just do a problem here and see how bad this actually is. So here's the problem we're going to work on. If I drink 500 milliliters of water, how many atoms of hydrogen would I be consuming? Clearly, you'd be consuming some hydrogen atoms because the water, we know, I hope we know, the formula is H2O. And if I figure out the molar mass of that, its oxygen is 16, and each hydrogen is 1, so it'd be 18 grams per mole is the molar mass. So the way I always start any problem is I write down the given, and the given in this problem you see is 500 milliliters. Now you'll notice it says milliliters, and that's a volume. So you might think that I could convert that to liters and then use my 1 mole equals 22.4 liters thing. I see students try to do that every once in a while. You have to remember that 1 mole equals 22.4 liters is only for gases at STP. This is not a gas, this is a liquid. So there must be some other way to figure out how many grams this is. Well, we know the density of water is 1 gram per every 1 milliliter. So instead of saying 500 milliliters, I can write down 500 grams. 500 grams. And now I'm going to draw my big long dimensional analysis line, and I'm going to have conversion factors that I could possibly put in here. I am trying to get to atoms of hydrogen. You always need to know where you're going. Atoms of hydrogen. So I'm starting with grams. I clearly don't want grams, so I just automatically take that unit and I put it down into the next conversion factor place. And I think, okay, what do I know with grams? What conversion factor do I have with grams? Well, I know that 1 mole equals the molar mass of something. So I could write 1 mole for water, 1 mole of water equals 18 grams. That's the molar mass right there, 18 grams per mole. So 1 mole over 18 grams, and my grams cancel out, and now I'm in moles. I don't want to be in moles, I want to be in atoms of hydrogen. So I would drop down moles here on the bottom, 1 mole. And what is 1 mole? What's another conversion factor we had? We had 3, and we're not using the 22.4 liters because we don't have a gas here. So really we only have 2 conversion factors to use, and we've already used one of them, the 1 mole equaling molar mass. So the other one we have is 1 mole equals 6.02 E23 representative particles. Now what is the representative particle for water? It would be a molecule. So I don't actually have to say representative particles. I could write molecules instead. And my mole would cancel out. So now I'm in molecules of water. So if I did the math right now, I would know how many H2O molecules there would be in 500 milliliters of water. But I'm going to take this one step further. I'm trying to do the most difficult problem I possibly could so you'd be able to be used to it. I'm trying to figure out how many atoms of hydrogen there would be. I know right now, if I did the math, how many H2O molecules there are. So this last step is actually, I hope, for you, pretty straightforward and easy. In every 1 molecule, I'm going to put 1 molecule of H2O on the bottom, so molecules will cancel out. In every molecule of water, how many atoms of hydrogen are there? Well, it's H2O, so there'd be 2 atoms of H. 2 atoms of H in every single molecule. And since I've already figured out how many molecules there are, then that will give me the total atoms of H. So now I do the math. I take 500. Remember how you do this. We do the top numbers, 500 times Avogadro's number. I'll just write this as a shortcut. Avogadro's number, 6.2 times 10 to the 23rd, times 2. And then we divide by all the bottom numbers. So I'm going to divide by 18. And if you do that on your calculator, you should get a big number, right? We're trying to find atoms of hydrogen. Those are very small. We're looking for a really big number. So 3.34 times 10, or E, to the 25th atoms of H. And that's how we do a mole math problem. Now, some of you might realize that, you know what, we could have taken this conversion factor and this one here and kind of combine them all into one. Since we have this 1 mole on the top, 1 mole on the bottom, we could have just taken this number here, over this number here. So it would have looked like, 500 grams, and then we could just say, and you don't have to do this. This is just if you really start getting a good grasp of this, then this will be a shortcut that you'll probably start using. You could say, okay, I know that in 18 grams of water, that's 1 mole, 18 grams is 1 mole, so that means that 18 grams is the mass of 6.02 E23 molecules. See, I would know that 1 mole is 18 grams and 1 mole is that many molecules, so I could just say that that means 18 grams is the mass of that many molecules of water. Keep in mind, it is of water. I mean, 18 grams isn't the mass of a mole, a 6.02 E23, atoms of copper or anything like that. It would have a different mass. It's a different substance. So eventually, if you really get good at this, you could take those two kind of conversion factors and really combine them, and you'd be almost done. All you have to do is say one molecule is 2 atoms of hydrogen, and then you could solve it that way. So I'm hoping that that one problem right there, since you can pause it and go back over it several times, should help you pretty much convert from anything to anything. You just need to start with your given and see where your units take you.